Final two trig functions, tangent and cotangent, okay? So sine and cosine went together, secant and cosecant went together, and they also went back with sine and cosine. I will say tangent and cotangent are their own thing, okay? They go together, but they don't really go back with the other four, okay? So as we look at tangent, first of all, these do officially have arrows on them. When I was typing these notes up, arrows just didn't happen, okay? So these do officially have arrows on them. And so the tangent curve is a repeated set of individual curves like this, okay? They look a lot like the cubic curve, yes? Remember the cubic curve, y equals x cubed, okay? Y equals x cubed is the one that we usually draw like that. Well, that's essentially what tangent and cotangent are. So with tangent, one of the key things, and I probably should have typed it on here, but I didn't. The period for tangent is pi. Okay? How does that differ from sine and cosine? Sine and cosine, a period was 2 pi, right? So the period was 2 pi for one cycle, which whether it be sine or whether it be cosine, okay? For tangent, my period is pi. And so what that means is that one curve fits in a period of pi. Now, in all honesty, so if you go here from negative pi over 2 to pi over 2, that's pi, right? That is one curve. So this actually is showing us two cycles or two periods of pi. And so when we draw our tangent and cotangents, I actually bump it up and ask you to draw 2 periods. Okay, minimum 2. That way we can see what's going on. But with tangent, the first thing you'll draw is the dot on the origin. And so when we're trying to differentiate between, okay, tangent versus cotangent, the first thing you draw is the dot on the origin. Now, if the period is pi, what does that mean happens once every pi? There is a dot. So that means the next dot is at pi. The next dot would be at 2 pi, 3 pi, so on and so forth. And then you've got that curve that fits within a period, but the middle of each period then is an asymptote. Okay, so we have these asymptotes. So if we put dots at 0 and pi, the middle of 0 and pi is pi over 2. There's an asymptote. Going backwards, the middle of 0 and negative pi would be negative pi over 2. So in this particular case, every whole pi is going to be a point, or a 0, I should say. Every half pi is going to be an asymptote. And then tangent is always an increasing curve. Now, something I can help you think of here. What is tangent as a fraction? Tangent is what over what? Y over x, or what trig function over what trig function? There we go. So I just want to make a connection here for you, okay? Tangent is sine over cosine. Well, with that in mind, when this fraction equals 0, how does a fraction equal 0? That means there is 0 in the numerator. So when this fraction equals 0, it's also going to be when sine equals 0. So my point there that I can make is that any zeros on sine are going to be tangent zeros. Does that make sense? So in other words, if we were to draw sine in here, sine, what does sine do? It starts at 0, it maxes, it crosses back through at pi, it mins, and it crosses back through at 2 pi. So do these zeros of tangent match up with zeros of tangent? Or zeros of tangent match up with zeros of sine? Totally said that backwards. Okay? Now, cosine. What about when cosine is 0? What happens when cosine is 0 and it's in the denominator? It's going to make that fraction what? What am I doing? I'm making all kinds of marks here. What happens when the denominator of a fraction is 0? Okay, it's undefined. It doesn't exist. So in this case, when cosine is 0, well, think about it. Cosine, when it's 0, it what? It starts at pi here. Where's the first place it crosses? Pi over 2, which is an asymptote. Then it's a min here, and then it crosses at 3 pi over 2. It's an asymptote. So anytime cosine is a 0, on tangent, that is an asymptote. Okay, so that's just an option of a way you can put it together. Okay, but in all honesty, tangent, remember with tangent you start on a dot on the origin. It's an increasing graph and the period is pi. So that means we're going to have a point every pi. Okay, asymptotes are in the middle then. Okay. Now, cotangent. Let's look at what changes. Cotangent, first of all, before I forget, guess what? The period is also pi on cotangent. Okay. But two big changes. First of all, the first thing you draw on cotangent is the asymptote. So at the origin, you know, with tangent we start with a 0. Cotangent we start with an asymptote. And so that means if 0 is an asymptote, once every pi, since it's a cycle of pi. So then 1 pi is an asymptote, 2 pi is an asymptote, so on and so forth. What's in the middle of the asymptotes then? The points. So the middle of 0 and pi is pi over 2. Middle of 1 pi and 2 pi is 3 pi over 2. And what's the other big difference with these graphs? They're reversed, aren't they? Instead of being an increasing curve like tangent, this is a decreasing curve. Okay? Now, I can relate it similar to what I did earlier. I just don't have the room over here. Yikes. First of all, what is cotangent as a fraction? Okay. Cotangent is cosine over sine. Now, think with me. If cosine is on top, that means when cosine equals 0, then also cotangent equals 0, right? So that means any place that cosine has a 0, cotangent has a 0. So I'm going to say cosine 0 is going to equal cotangent zeros. Let's see, cosine it starts high, it crosses through at pi over 2. Minimum, crosses through at 3 pi over 2. Those zeros match up, don't they? Sine is in the denominator. What happens when sine equals 0? Yeah. Sine equals 0 is going to make cotangent not exist, because it's going to make that fraction not exist. That means there's going to be an asymptote. So those are going to be cotangent asymptotes. Okay. Do you have to think through this side part? No, you don't have to. But if you get confused and you forget something, it's a connection that does exist. Okay? Now, best thing to do is to get in there and try some examples, right? Okay. Let's look at this chart here. And as we look at this chart, it was pointed out, my letters are the same, yes? A times tangent or cotangent of bx minus c and then plus d. So that means there are definitely some similarities. Okay? Let's see. if we talk about similarities, D is still the center line, yes? Okay, that's how far your graph is going to shift up or down. Now, in the past, A has been our amplitude. See, you remember stuff, okay? It's our amplitude. How far up or down we count. Well, those tangent and cotangent graphs, we're not really counting up and down, aren't we? So A is going to be our stretch or compression, technically. Okay, so if A is a number out in front, if the absolute value of A is bigger than 1, it's going to stretch it, okay? That means it's going to be a taller, skinnier graph, and I'll demonstrate, okay? If A, the absolute value of A is less than 1, think of it like a vertical compression or vertical shrink, where it's going to be, I don't know, shorter, squattier, okay? It stays closer to the x-axis, okay? And again, I'll demonstrate a visual of, the difference, but I'll do it when we talk about graphs, okay? But you need to be able to recognize it is a stretch or a flatten. Of course, if A is negative, that's going to flip the graph, okay? Now, period. Period is what? Why is it pi over b? Yeah. What was our period in sine and cosine? That was 2 pi, so we did 2 pi over b in sine and cosine because the period was 2 pi. Tangent and cotangent, the period is pi, so to find the period, we just do pi over b. B still being the coefficient out front, right? Phase shift is still going to be c over b, and of course that's going to be opposite the direction of the sine. Okay, you ready? Let's try number 1. Number 1, y equals 2 times tangent of 6x plus pi minus 1. I don't give you a soft lead in here. We're jumping all in. Okay? Let's see. Start in the normal place, I guess, center line. Center line is -1. I will say it's easy to forget to label it on this one because we don't have the amplitude we have to label with it. So now, instead of amplitude, what are we talking about this time? Okay. Our A value is vertical stretch or shrink, or flat stretch or flatten is the wording they use here. And so this is going to be a vertical stretch. And it's a vertical stretch by a factor of 2. Not that you're going to label 2 or count or anything. It's just that's what the value is. Let's see. What should I talk about next? Period. Thoughts about the period? Are you guys with them? It's supposed to be pi divided by b. Pi divided by what's b? It is that 6. And we need to talk about a phase shift. What about our phase shift? Okay. Phase shift, this is the same old, right? C over B opposite the sign, so it's going to be pi over 6. Since that's a plus, we're going to say minus, or you're going to write the word left. You're going to do something with it. Okay, do we have everything? I guess the other thing I would say, okay, what is it we're graphing? We're graphing what? Tangent. And what does a tangent curve look like? It is an increasing curve, yes? That's, sine and cosine, I would always kind of draw, okay, what is it? Mountain, valley, valley, mountain, it's reflected. Is it a mountain? I always kind of drew that in. This is what tangent is. Okay, so let's get some labeling, and then we'll go from there. I will say, I think the I don't know, I personally think the labeling's a little bit easier with tangent, cotangent. You may choose to disagree, but. Okay, don't forget to start off labeling your center line. Either label it here or label it in the center. Label it somewhere. I don't care which. Just don't forget. And I say that because I feel like it's, occasionally we'd even forget to label the others, but you don't have any amplitude to go with it. So, okay. Now, in terms of labeling this other direction, okay, our period is pi over 6. When we go to label our periods, the difference here is we're not going to have to take a period and break it up into 4 pieces. We're usually just going to take a period and break it into 2 pieces because you just have to be able to label the halfway point. Now, the other thing is, I want you to do a couple of periods, okay? You don't have to do a ton, but I want at least 2. So with that in mind, my period is pi over 6. So I'm going to start by labeling pi over 6s. I'm going to give it a little bit more space than I would. And I treat this differently. I just count out, okay, there's pi over 6. That's 1 period, yes? Then I'm going to go and label another of the same period. If that's 1 pi over 6, what's this one? It's 2 pi over 6. Or what can we call 2 pi over 6? Pi over 3. Okay. And I'll be honest, I'll let you slide either way. Right there, that is 2 cycles of, that's enough for 2 cycles, isn't it? Other than, which way is our shift taking us? Left. So should we probably go and label equivalents of left? Yeah, because we're going to have to go left. So I'm eyeballing. Are you guys kind of keeping these the same? There's my negative pi over 6. Okay. Now, here's the deal. Every pi over 6 is a cycle. Well, we need to mark the midway points. So midway points, you got options, right? One option is to just make a tick mark. What's the middle of 0 and pi over 6, just while we're talking? No? A half of a sixth is a 12th. So this would, if you want to get fancy, it's the only one I'm going to label just because it gets to be too confusing, but that is a 12th. Regardless, we need a tick mark between 0 and pi over 6. We need a tick mark between pi over 6 and 2 pi over 6. And of course, that means we should have a tick mark between 0 and negative pi over 6. You might hit a point where you need some more marks later. We can see what happens here. Okay? Now, what is it we're graphing? We're graphing tangent, yes? Go back to the top of your paper. What does it say about tangent?
First thing.
Okay, so as you set this up, we're basically going to draw our dots and asymptotes, and then I'll put the curves in. So the first thing we do with tangent is a dot on the origin. Now, pause and thought. A dot on the origin. But what are we doing with this particular problem? This dot on the origin needs to shift left, yes? So is there actually a dot on the origin right now? Not yet. Maybe later, maybe not later. So the dot that's supposed to be on the origin, we're going to shift it left, and that puts us at with a dot on negative pi over 6. Are you with me? How often do I put dots then? Once every period. What's my period? Pi over 6. So once every period, I'm going to put another dot. So right now I have a dot at negative pi over 6. If I add pi over 6, where does that take me? 0? So technically, did I end up with a dot on 0 also?
Yeah.
I did. And that's only because my period and phase shift are the same. Okay, that's not going to always happen. If we go a little farther, where else would be dots? Pi over 6 and 2 pi over 6. Okay? Those are dots. Those represent once every period. What goes in the middle of every period then? An asymptote, okay? So here we had dot, dot. In the middle of them is the asymptote. So that means where am I going to put asymptotes? Okay, between 0 and negative pi over 6, there's an asymptote. Or in other words, negative pi over 12. Between 0 and pi over 6, or in other words, at pi over 12, there's an asymptote. And based on what I have on my graph, between pi over 6 and 2 pi over 6, there's an asymptote, or between pi over 6 and pi over 3. We really easily ended up with more information than what we needed there, didn't we? Now, and you could put in asymptotes on either end if you want. Because technically, what happens if I go left of negative pi over 6? There would be an asymptote, yes? Okay. You're ready to draw your graph at this point. Now, what's a tangent graph look like? It's an increasing curve. Vertical stretch just means we are cutting through and we're not really lingering at the x-axis, okay? So my first cut through is at negative pi over 6. So I'm going to have something, let's see if I can draw it how I like it. Something like that, okay? It's pretty vertical. Hop over the asymptote, draw another one. Okay? And we only have to have 2, but did we set ourselves up for 3 accidentally? We did, it happens. It's really easy to give extras here, and that's perfectly fine. And in fact, could you do a 4th if you wanted to? You could. You don't have the other asymptote for it, but you could easily say, you know, okay. Now, when I'm grading these, which one was kind of our starting one? Excuse me. This one right here, yes? So, like, as I'm grading, that's the one I would generally be looking for first. Like, that should be your base. No, I'm not saying you have to start, but that should be your base, and we'd look to add on from there. Okay, questions?
So, like, the vertical, like, for the stretch and the flatten, we never really do anything with, like, the number. We just kind of, like...
It's more of it's more of just a visual effect, okay? And we'll probably have a flatten coming up next if I have to guess without even looking. And so I will demonstrate what the difference would be between a stretch and a flatten then. But the flatten, the idea is it's going to end up being kind of almost appearing wider, and it's going to run along that x-axis almost. Or runs closer to the x-axis. Sorry, guys. Okay. You start working on the next one? Okay, what do we know? There is a center line of 3. You know, if you want, you could go ahead and throw that 3 on there right then, couldn't you? Not saying you have to, but so easy to forget. Or put it here at the center, either or. Okay, what else do we know? Okay, we're going to vertically flatten by a factor of 1/2. This means instead of stretching away from the x-axis, it's going to be pulled closer to the x-axis. Again, I'll try and demonstrate. What else should we talk about while we're there? Okay, there's a negative in front of that 1/2, so there is going to be a reflection. That is going to be a reflection across the x-axis. Oh, you were stretching. I thought you had a question. Okay. Now, while we're here, let's talk about this. Reflection across the x-axis. What's that going to do? Flip it. So if we think about, what graph are we graphing here? Cotangent. What's a cotangent graph supposed to look like? Okay, cotangent graph is supposed to be decreasing. But what's the reflection going to do? It's going to flip it upside down, and now it's going to be increasing and essentially look like a tangent graph. But we're still going to follow cotangent rules of where to place it. Okay, thoughts on the period? Okay. So pi divided by b. B is the coefficient of x. Well, I made it as x over 2. Realize x over 2 is the same thing as thinking 1/2 x, right? So pi divided by 1/2. We've talked about this last week, right? Pi divided by 1/2 is multiplying by the reciprocal. So we have a period of 2 pi. And what about a phase shift?
Pi over 4 times 2
Is she right? Let's see, c over b. So pi over 4 divided by 1/2. Okay. I just hadn't looked at my answer key, honestly. I hadn't processed it. So pi over 4 becomes times 2 over 1, which is 2 pi over 4, but we say that as pi over 2. And left or right? Be pi over 2 to the right. Okay. Let's see. Label your center line, yes. Which, 3, one of those two places, whichever. We need to label our period, yes? Now, with this in mind, our period is going to be 2 pi. So we need to label 2 pi. However, this is tangent cotangent day. How many cycles of tangent or cotangent do I want you to draw? 2. So if one cycle is 2 pi, and I want you to draw 2 cycles, we need to go out to 4 pi.
Yep. We need to go out further than 4 pi since it's
So technically, she beat me to it, but yep, that's exactly what I need you guys thinking. Technically, you're going to need to leave a little bit of room to go a little past 4 pi because we have a phase shift that takes us to the right, yes? Not much, but a little bit. So I did leave myself a little bit of room there. See, there are issues with sine and cosine that carry over. You have the general idea. Okay, so 4 pi. Well, a period is 2 pi, right? So we're going to break this. So right there, 0 to 2 pi is a period, 2 pi to 4 pi is a period, right? In each period, what do I always need to mark?
midpoint.
The midpoint, right? So from 0 to 2 pi, the midpoint is going to be pi. From 2 pi to 4 pi, the midpoint is going to be 3 pi. So now I've got 2 cycles and their midpoints marked. Yes?
Yeah.
What else do we need to consider, though? My phase shift is pi over 2. Do I have my pi over 2s marked?
No, but we can.
No, but we can, and we're going to have to, aren't we?
Mm-hmm.
Okay. What are my pi over 2s, though? They're easy. Okay.
pi over 2.
0 to pi, we just need to mark the middle is pi over 2, right? Each of these, so we're going to add one more set of marks.
We have to label them.
No, not necessarily. I'm going to label my first one, just, reminding myself that these are pi over 2s. I guess as I look at my notes, I do have them labeled.
All of them?
I do.
Are we ever choose live?
No, you're not required. I mean, if you guys, getting the idea, minimum like every other one labeled, know what they are, So what would be between 1 pi and 2 pi? 3 pi over 2. My brain says 1.5 pi, right? If you're looking for a way to figure it out. What would be between 2 pi and 3 pi?
Well, you know that one.
2 pi over 3. No,
Incorrect.
that's not
That,
right.
wow. 2.5.
2.5. Make that improper now. See, my brain says, okay, 2.5.
3. Or 3.
Improper.
Oh, wait.
2 times 2 is
5
4 plus 1. 5 pi over 2. See, this is why I talk about this, because it's good fraction review. What's the middle of 3 and 4 pi?
7 pi over 2.
Or now maybe you're noticing the trend, right? It's 3.5 pi. If we're going to have to go one more, what's 4.5 going to be? 9 pi over 2? I don't know. On my paper, it doesn't look nearly so crazy in there, but okay. We ready? What graph is our brain supposed to be thinking? Cotangent. Okay. But I'm not going to care about the reflected right now. I need to follow the cotangent rules. Okay? Do you understand what I'm saying there? Yes, we're going to reflect it. It's going to look like tangent, but I don't care about that yet. What are my cotangent rules? Draw the asymptote at the y-axis, okay, at the origin. So, if I'm going to draw an asymptote here, this would be drawing the asymptote without any phase shift. Where's my phase shift going to take this asymptote? Pi over 2. So I'm going to draw an asymptote at pi over 2. By the way, do you guys see why I'm not trying to draw the original in before a shift? It would be super duper confusing because asymptotes and points, you wouldn't know what's old and what's new. Okay? Now, there's my first asymptote, yes? I need to draw an asymptote once every period. What is my period? No.
2 pi.
2 pi in this problem. So here's my first asymptote. You need to go 2 pi and draw another asymptote. Now, think about this. This was just pi over 2 from 0, yes? So basically, where's 2 pi farther going to be?
Yeah.
I heard a lot of different things. Are we between 2 and 3 pi?
Yeah.
Because here's the deal. We start at 0, but we move pi over 2 right. So if you're going another 2 pi, go to 2 pi and move pi over 2 right. Give me one more asymptote.
The one right after 4.
Right after 4 pi, right? Because if you're right after 0, right after 2 pi, then you are right after 4 pi. Okay, you got your asymptotes. Okay, where are your zeros, your points? She says right there. Okay. Okay, your zeros are the midpoints there, right?
3 pi over 2.
So in this case, between pi over 2 and 5 pi over 2, we're going to have a 0 at 3 pi over 2. And we're going to have a 0 at 7 pi over 2.
Duh.
So my 1, 2, 3, and 4 pi's didn't get used at all. But we need them there for positioning. Okay, what are we drawing?
A flattened, reflected cotangent.
A flattened, reflected cotangent, which really could just become a flattened tangent, yes? So because it's reflected cotangent, it's going to be an increasing curve instead of decreasing. Flattened, the idea is that instead of it more,
Oh, I joined the wrong way. I knew that.
Okay, and I guess here's what I'll show you in Men Ready to Erase this second one. Do you see a difference between how I drew those two? They're not the same, right? And the idea is a flattened one pulls closer to the x-axis. I'm getting ready to erase this second one and redo it. This is more of a stretch because what does it do as it crosses through the x-axis? It keeps going. It's pretty vertical. This one kind of horizontals out and then goes back vertical. Am I making sense? I just wanted you to see the difference. Now, here's the deal. Whoops. What I have to tell you is when it comes homework and quiz time, you have to sell it to me and make me believe it. Because it is, and that's why I'll grade the homework, right, to give you an idea of what I'm believing. But I don't have a number to grade here. It's okay, do I think that they went back and said, oh, flatten and tried to make it flat? Okay. Tomorrow, we'll finish 2 examples. We will go over, you'll have some work time on tangent, cotangent. You can grab the worksheet today if you want it. Wednesday, I'll have the review worksheet for you. Friday, quiz.
I love